Hello everyone, this is Dr. Milind Kirikere, and today I'm going to discuss with you what is the scope of CAD CAM in product life cycle. Now to start understanding about product life cycle, first let us try to understand what is a product. Now you can see a product is something which is tangible, which can be physically felt, which can be transferred, which can be owned, which can be traded and distributed to different places at different times without changing their identity. So I've put some photographs on the slide. You'll easily understand by watching it, looking at the photograph, what I mean to say. The photographs are of Mercedes-Benz, then Bose headsets, then Samsung mobile phones. You go to any corner of the world, the value of these products does not change. So you can transfer it, you can trade it across all corners of the world. The product is something which is tangible, which can be physically felt, and which can be transferred. Okay, so any kind of good can be categorized as a product. Now, having discussed about a product, let us try to understand what are the qualities of the good product or what are the things which make any product good. First is usefulness. How much the particular product which you have manufactured, your company has developed, it is useful. Okay, so that is first and foremost important quality of any good product. Then explainability. Whatever product you have, let us say for example mobile phone, it should be able to explain all its features in best possible manner with the best possible simplicity in the simplest way to the user. That is the second quality of a good product. Third is again simplicity. So how simply it is designed. Then scalability. If suppose you are planning to develop a particular product, it should be easily scalable, and that basically decides whether the product is of good quality or bad quality. Right? And habit generation. In all good senses, whatever product you are developing, it should be able to generate good habits, or it should be able to make the users habitual of its use. Okay, so that is the meaning of habit generation. Now let's take an example of Microsoft operating system. It fits in all, it satisfies all these five qualities, and that actually makes any product good. Usefulness. Is Microsoft operating system useful? Yes, it is useful. If you start using the particular operating system, it is simple to understand as compared to many other operating systems. Whatever functionalities it has, it has those are easily explainable. Scalability, since it was launched and since its very first version, now it has been scaled. So as of now, Microsoft has 76.5%, 56% of the market share as far as operating systems all over the world are concerned. And it is a very good example of habit generation as well. There are many other operating systems in the market which are freely available, but still most of us prefer to use Microsoft operating system because it has so many good qualities. So I have drawn a triangle over here. The base starts with usefulness, then as we go on moving upwards, it covers explainability, simplicity, scalability, and habit generation. It forms the epitome, correct? Each use adds value to the user. So that is again one more very important requirement. As and as and when you start using the particular product, and as you go on using it again and again, and for number of months, number of years, it should go. You should feel, you as a user should feel like the product is adding some value to you as a user, and it should reduce likelihood that you will look for any other option in the market as far as that product is concerned. Okay, so these are some of the good qualities of the product. Now after looking at the qualities of the good product, let us try to understand what is a product life cycle. Typically we have the notion, we feel, we as a student, we as a learner, we feel like the product life cycle or product life starts from the point from which the product is actually sold to the market, and it ends when user stops using it. But let me tell you, it is not like that. Basically it starts with the research. When the research team starts finding out the pain points to meet a particular need of society, need of a particular company, or whatsoever it is. Okay, then first the research team starts researching about the particular pain point. Then the concept gets developed. Then the team decides how the product should look like, what features should be there. Then actually product is designed. Then all the calculation part is carried out. Then prototypes are prepared. Testing is done. Then actual product is manufactured. Physical product is manufactured. If there are a number of components, those components are put together and assembled together. Once the final product is ready, it is sent for the distribution through various distribution channels, and through those distribution channels, those are delivered to the customers, and customers are using it. Uh, Product serves the customer to its intended purpose for so many years, and then finally, when the product life comes to an end, it goes to the state of liquidation and it is recycled. So let me tell you, the product life cycle starts from the point where actually concept gets birth in the mind of the designer or product developer. They start researching upon it, and it ends when the product is sent to liquidation, and it is sent to recycling purpose. It is put to scrap. So it is just like what human life cycle we consider. So the human life starts with the womb, which is in the uh, inside the mother's body, and it ends when the particular after the death, when the particular body is put to ashes. Okay, so that is the product life cycle. Now, mechanical product development process or mechanical product life cycle is slightly different as compared to other products. Basically, let us try to understand how mechanical product development process uh, is carried out. First, product requirements and specifications are jotted down, and description of desired product characteristics is actually presented and actually prepared. Then, based upon the description and product characteristics, whatever requirements are to be fulfilled as far as customer requirements are concerned, we know that any product basically is intended or designed to meet customer requirements. So accordingly, definition of the requirements, then specifications, then as per the requirements, and the target specifications are decided. So that is the first product requirement and specification stage. Then comes the functional concept. See, concept basically design people or product design people, they work on the concept. Functional concept, it consists of development of functional structure, then how the product will look, what kind of functions will be there, what kind of sub functions will be there. So that kind of layout will be prepared under functional concept, and all the description of the functional configuration or interactions is put under the functional concept. That is the second phase. And the third phase is physical concept. So actual product composition, what the product will consist of, there could be various assemblies, various components could be there. So all this composition is developed in the physical concept, and whatever functions are there in order to perform various functions in a particular product, in a particular mechanical product, to be specific, there are number of associated mechanisms which are required to be designed, which are required to be simulated, animated. All those things are done. Then the dimensioning part is done, dimensions are decided, calculations are done, and actual testing is done. And then comes the product design, actual product design, wherein shape, size, and all the functionalities, how the product looks, what kind of materials will be appropriate in order to manufacture or in order to develop a particular product, that is decided. Calculations are done. Then if required, optimization in the various product geometry, shape, and sizes, or material optimization is done. And then last stage in the mechanical product development process is product related development, like production, actual production, assembly and inspection oriented development, manufacturing related optimization, and finally it ends with product documentation. So whatever processes have been carried out in mechanical, entire mechanical product development process, each of the process and sub process is completely documented so as to make the life of entire design team easy. So it may happen that at any point of time, that if some of the members of the entire design or development team leaves the organization should not become paralyzed. Correct. So that is the purpose of having documentation of everything. Okay. Moving on, let us try to focus on what challenges the modern days businesses are facing. Now there is very much resemblance or very much relevance as far as the product development process, then product life cycle, and these challenges are concerned. Now, four challenges majority you'll find any manufacturing industry or any mechanical industry or any kind of industry is facing. First is variety, second is quality, third is cost, and number four is time. How to meet these challenges? Now, before moving towards meeting these challenges, let us try to understand what is the meaning of variety. Variety means, you take an example of mobile phone. These days in market, there are so many number of companies who are offering so many number of different designs of smartphones, different sizes, different shapes, different colors. So you take the name and the thing is available to you, right? So that is the variety. I'll tell you a story. When Ford Motors was number one in the world back in 19th century, Henry Ford was the founder of the Ford Motors Corporation. So at that time, they used to manufacture a model called as Model T of the Ford motor, and that too with black color. And Mr. Ford used to say like, customers will have to buy Model T and that too with bicolor as long as they want to buy a car. So that was the scenario during that time. Can we imagine such kind of things? These days, there are so many car manufacturing companies into the market. They are offering whatever you want. You probably might have heard about mass customization, but let me tell you, these days industry is moving from mass customization to mass personalization. I'll not touch upon it because that is not within the scope of this particular presentation. So I'll not touch upon this, but at later point of time, I'll definitely speak upon mass personalization. So that is about variety. A lot of variety is available. Second is quality. Quality is of foremost importance. Let us take an example. Let us assume that you have procured a particular part, or maybe a particular good from the Amazon or maybe Flipkart. If you don't find the quality meeting your expectation, immediately you give the review. You write the review wherein you deny its acceptability or its acceptance, whatever claims the particular company has made in or regarding related to the quality, you deny. So you write review accordingly. Your review is referred by thousands and lakhs of customers, and that actually creates a dent in the market of the particular company. So maintaining highest quality is very important. Again, I have one particular example for you to tell regarding the quality. Long back, it so happened that IBM, they decided to get some components manufactured, rather 10,000 components manufactured from a Japanese manufacturing firm. And in the specifications, it was mentioned by the IBM company that three defective components can be accepted per 10,000 number of pieces, number of components. And I'll tell you what happened. There were two separate consignments sent by that particular Japanese manufacturer, wherein 10,000 components with zero defect were there in one consignment, and another consignment, it did consist of three components, that is, those were defective components, and the letter was written, covering letter was written, we don't know the mentality or philosophy of American businesses, but sending three defective pieces as desired. I hope you understood what is the meaning of quality to Japanese. They work upon zero tolerance as far as quality is concerned, no compromise with quality at all. Number three is cost. Whatever best quality product you manufacture, if you are not able to keep the cost minimum, I'm saying minimum, you may lose most of the share of market. Correct? There is certain class in the market who prefers Mercedes Benz, who prefers BMW and all that kind of stuff. But majority of the people in the market, in the society, they prefer low cost products. Especially that is a mentality of Indian customers. So cost, it must be kept as low as possible. And number four is time. You have to hit the market at perfect time, at right time. If you get delayed even by 1 month, there is some another competitor sitting in the market, he'll take over you, and you'll be losing most of your market share. So these are four major challenges being faced by the companies. How to overcome these challenges, how to meet these challenges? So we'll try to understand how to meet these challenges. Now the answer to this, in my view, is CAD. Basically, without CAD and CAM and CAE, whatever products we are using these days, it wouldn't have been possible at all. I have put two pictures on this slide. On left hand side, you can see design office in 19th century, 1900s to be very precise. You can see lot many engineers or draftsmen were there, and very big size drawing boards were there, and very big size sheets are there. Sheets would be there, and the draftsman actually would used to lie upon the sheets, and they used to draw whatever drawings were there on the sheets, correct? And right hand side picture shows Zen office in 2020. You can see very sophisticated computers are there, and in front of those three four uh, design engineers are sitting in very sophisticated offices. They have scanners, they have printers, they have everything. The things have changed dramatically, drastically, and with a pace which is actually practically unbelievable. Okay, so CAD is the answer to meet those challenges which are being faced by the businesses these days. Now, what is CAD? Basically, by definition, if we go, it is the use of computer systems to perform certain functions in the design process. So, what are the various aspects of CAD? First is modeling, second is display and visualization, and third is applications. Now let us get to the modeling. Modeling basically it consists of various functions like computers are used for designing. So computer basically it consists of hardware and software. Needless to mention, that is used for designing of various products. The numerical methods are used like finite element analysis for the purpose of optimization. 2D and 3D drafting is done, which comes under the umbrella of modeling. And 3D modeling is done for better visualization. In case of 3D, always the designer uh, is able to view a particular component, particular object in a far better manner as compared to 2D. And then you can model any intricate shape curves, maybe surfaces, maybe mechanisms you can have. You can simulate those mechanisms, you can simulate various assemblies. So all kind of capabilities are there in the modern CAD tools, in the modern CAD software. So I put three pictures on the particular slide, wherein the first picture is about it shows 2D drafting. Second picture it shows the animation of a 3D model, and the third picture it shows 3D model of a computer mouse. So these are the activities which are coming under the umbrella of modeling. Again, in remodeling, you'll find there is typical set of activities like define the object first, then define the relationship between the objects, define the properties of the objects, and define the orientation of the objects in the suitable coordinate systems. And if you want to I mean, edit existing definition, that also is possible under the modeling kind of thing, modeling activity. Okay. Now, second major activity under CAD, which is display and visualization. Now, whatever finest object you have drawn by using any CAD software, it needs to be displayed very beautifully. It needs to be visualized from all sides, from all corners, under all circumstances. Now, in order to enable the designer to have to enjoy to have these particular facilities, there are various means which are provided to the designers when he or she is using any CAD software. So displaying of the model, it basically requires mapping or transforming object onto the screen coordinate. Now see, models are typically made in model coordinate system. It may vary from one particular model to another model. This could be even the world coordinate system, and a local coordinate system as well. These coordinate systems are typically three-dimensional in nature, if you look at those. Now to display object on a 2D screen, the object coordinates needs to be mapped to the 2D coordinate system on the screen. Now this is done in two steps. First is called as viewing transformation. Under viewing transformation, the coordinates of the objects are transferred so as it gives a feeling like the particular person is looking at the object through the screen, and the coordinate system is referred to or referred as the viewing coordinate system. And second is projection. The object in the viewing coordinate system is then projected onto the two-dimensional plane of the screen. Then comes surface display or shading and rendering. Now, shading and rendering, it means In order to have very good feel of a three-dimensional shape of an object, you can render various effects. It may be in terms of texture, it may be in terms of shade, it may be in terms of color, and so on and so forth. So this basically requires special techniques to render the surface based on its shapes and lighting conditions as well as the textures, as I said earlier. And then comes hidden line removal when multiple surfaces are displayed. So we are going to see what is hidden line removal in detail. There are various algorithms which basically decide in case of the 3D models, which lines, which surfaces are to be displayed first and which surfaces are to be obscured or to be kept behind. That is decided by various algorithms. And third part of CAD is applications. So what are the various applications of CAD? You can use CAD for stress analysis, by using numerical methods, finite element analysis. Then you can use the CAD for simulation for actual purpose, for actual use. Then you can optimize the things by using CAD and other applications, like you can integrate any CAD software with the CAM software. This example is SolidWorks can be integrated with CAMWorks. There are a number of such kind of softwares which can be integrated with CAM softwares as well. Then you can use CAD for process planning as well. Okay. Now this particular figure shows you a typical product life cycle. You can see two parts are there. One upper part is the design process, lower part is the manufacturing process. And again, the CAD process or the CAD part in design process is highlighted with the gray color, and CAM part in the manufacturing process is highlighted with the gray color on the lower side. Now I have written synthesis and analysis. So analysis and synthesis are two different aspects. So if you look at typical product life cycle, it starts with design needs and design definitions, as we discussed earlier. Then the design team collects relevant design information, feasibility study is carried out, then design concept is created, then modeling and simulation is carried out, it is analyzed, optimization is done, and finally design is evaluated and documented and communicated to the concerned persons, especially to the manufacturing people. Process plan is prepared by the manufacturing people as for, with reference to the design which is communicated to them. Then production planning, design and procurement of new tools, ordering the materials, then programs creation for NC, CNC and DNC, and then finally the production is carried out. After production is carried out, quality control, quality checks are there, different processes are there to check the quality, and finally when quality is found to be satisfactory, up to the mark, it is the product is packaged and shipped to the end user, end customer, uh, and uh, final last stage is marketing. Okay, if suppose after selling some issue is there with the product, then marketing people, they are continuously in touch with the end users and they keep on collecting the feedback. Again, the feedback is given to the design team. Design needs are modified if required based upon the feedback. So this is how actually the product life cycle works. This is how the process works. Okay, let us have a look at use of what are the various use of CAD and CAM in product lifecycle management. I'll just go on reading this because each of these is a separate topic, and again, it is not within the scope of this particular presentation. So I'll not touch upon each and everything in detail. I'll just tell you what it is. So as far as CAD is concerned, geometric modeling, you know what is geometric modeling. Then engineering analysis, can perform the analysis. Mass property analysis also can be performed. Interference checking in case of uh, assembly, when you are assembling multiple components together, if interference is there, that checking also can be done with the help of CAD. Tolerance and stack up analysis is done, finite element analysis can be done, then kinematic and dynamic analysis is done, design is reviewed and it is evaluated as well. You can have design score, you can calculate design score with the help of CAD softwares. Automated dimensioning can be done, errors if any can be checked with the help of CAD softwares. Plant layout design can be done, and if you are preparing different layouts of the plant, then in that case you can even calculate design scores, plant layout design scores, and based upon the particular score you can select the particular plant layout design. Rapid prototyping, RP, again CAD is used for RP. Virtual prototyping also CAD is used for that. Discrete event simulation and animation also can be done with the help of CAD softwares. And finally, automated drafting. So there are various uses of CAD in product life cycle management. As far as CAM is concerned, Bill of material can be prepared, scheduling, forecasting can be done, NC manufacturing simulations can be done. Then part manufacturing planning is done, assembly process planning, factory layout and designing. Robots, if they are there on the shop floor, those can be programmed and simulated. Computer aided process planning, that is CAPP, again it comes under the umbrella of CAM. Production and inventory control is managed by CAM softwares. Machinability data systems, data analysis can be done. Then computer-aided line balancing is done, process monitoring and control also it comes under CAM, and even shop floor is entirely controlled by CAM softwares. So this is how you can incorporate CAD and CAM to perform various activities, to automate various activities in the process of product life cycle, and in for the purpose of managing or management of the entire product life cycle.